Hi, I'm Sophi Kravitz from Hackaday. I'm here at Electronica in Munich, Germany, and I'm here with Massimo Banzi and Dario Pennisi. Hi.
Hi.
Yeah, nice for you guys to be here. What's going on at Electronica? Are you having a good show?
Yeah, it's great. Yeah. We're mostly focusing on, talking to professional users about some of the products that we designed lately, which is more of the MKR family, so more like small connected nodes.
Okay.
And it's been very good because we have a lot of conversations with a user that's not a classic user of Arduino products. It's like a lot of people who are system integrators. They build complex systems where a lot of IoT is part of it, but they don't want to deal with hardware. So they like when there is something modular they can put together.
Right. What are some of the applications you're seeing here?
Well, so we've been talking to people doing all sorts of things. There's always a lot of people doing precision agriculture,
Okay.
which is also the kind of people we work with now with different companies doing that. So sensing in the field. We even work with a company that senses the size of pears on trees.
No way.
Yeah.
And so what, they classify pears by size?
Well, what they put these sensors on trees so they can measure how the fruit is growing and to figure out when it's the actual time to pick up the fruits.
Amazing.
Yeah?
I guess there's a soft robotics application in there too to get the fruit.
No, they probably have like a regular person, but at least they don't have to walk around all the time figuring out. So, but anyway, so that's one of the applications everybody loves. The pear sensor is good. But it's also a lot of people involved in logistics of different kind, environmental sensing of different kind, even kind of vehicle type hacking. So we work with a company that is basically creating accessories for tractors. So they hack into the CAN bus of the tractor and do crazy stuff. And we also introduced a professional LoRa gateway. It's a fairly sophisticated LoRa gateway that we developed with a company that builds LoRa networks for cities. So they are like high-end smart city stuff. So we build together something that connects to our cloud. It's very easy to set up, that kind of stuff. So that's kind of the stuff that
You
we're.
have your own cloud. There's an Arduino cloud?
Oh yes, there is an Arduino IoT Cloud, which is currently in beta. And actually I think there's a sign up somewhere where people can ask. It's designed to be super simple. So you connect the board to this website, you basically do like a few operations, and after like 5 minutes you have a board with a dashboard talking to it easy.
What comes next?
Well, there's, of course, we are pushing hard on the Maker family. Right now, Maker family is based on, let's say, a common computing module, which has a lot of different communication modules for LoRa, for Wi-Fi, Sigfox, NB-IoT, GSM, and so on. So we're going to expand on this, and most importantly, we are going to create a lot of content to help people develop applications, so that, of course, Arduino's mission is to make things easier. So we want to create as much as possible, let's say almost finished products, not just samples, but really finished applications that people can use to make their own, let's say, hack. Right?
Can you tell us what is in the module? Tell us about the hardware.
Okay, for most of the boards we are using modules from U-Blocks. So the Wi-Fi ones are based on the ESP32. As opposed to most of the stuff that you find around, these are made by a very reliable company, so modules are pre-certified, and we have guarantees on temperature and on, let's say, the overall functionality on temperature and so on. And on that, we are developing our own open source software. It's not released yet, but it will be soon. And for that, we have an open source stack for both Wi-Fi and Bluetooth, running on the ESP32. On all of the MKR boards, we have this new form factor of connectors, which have a total of 28 pins. We have 8 analog pins and several digital pins, some of which are usable also as PWMs. So, of course, we have created a set of add-on boards and carrier boards, which allow us to have sensors, actuators, and so on. So, for example, we have a motor shield, We have sensor shields with breakout boards and so on, and that is of course growing. We are moving, let's say, I wouldn't say I'm moving away, but we created this new form factor which is smaller and more thought for the industrial market. Then on some other boards, such as Vidor, the FPGA one, we also added a mini PCI Express connector where we have a lot more pins on which we can do more stuff. Also because those are connected to the FPGA, and with that we can have a lot more things to play with.
So we recently received 20 Vidor boards and we haven't had a chance to play with them yet. I hear that there's going to be a lot of really exciting content coming out soon for it.
Absolutely. We already released a couple of libraries which allow you to do a lot of things already. So you have, there's one library that's aimed at adding peripherals. So you have something like 6 or 8 serial ports, 3 I2Cs, SPIs, and many more stuff. And then there's another another library that allows you to have HDMI output with, let's say, software and hardware acceleration for drawing graphics, which is compatible with the Adafruit graphics library. We have PWMs, we have quadrature encoders, and a lot of them. I mean, any pin can be configured as PWM, so you can have as much as, I think, 25 different PWMs. You can have 11 encoders. And you also have a camera input from a Raspberry Pi camera interface. So in the same space of, let's say, a board that only has Wi-Fi, we crammed in all of this stuff. That we are working very hard to make it super simple. I mean, my basic concept 4 years ago was really rough, and he's really giving a good, big contribution to make that usable by anyone.
So yeah, my main responsibility now is really to kind of try to get all the different parts to fit together, because the stuff that we do now is very different from what people are used to. Everything we do now has a cloud component, has a bunch of tools, the connectivity, there's a bunch of different things coming together. So we're working a lot on the user experience and how to make it easier for people to just do stuff.
How do you know if the user experience is going to be good? Are you running around talking to people?
So there are different things that I do. So a lot of it is based on our experience of building tools for a long time. The second thing, sometimes I test some of these tools with my students when I teach. Okay. So in a way, the original Arduino came out of me working with my students. So then the other thing there, sometimes you also do like proper user testing. So for example, on the cloud now, we have a tool that tells us how the people are using the product, and it tells us where there are kind of issues, so we can analyze the way they use it, and so we're iterating the design constantly based on that.
Do you have a beta program set up for users? If we wanted to encourage people to check out your product and test it.
Yeah, so we're actually moving to a stage where we will have a more formal beta process. So we're trying to put together a group of up to about 100 people that really want to do this with us. So we're going to send them stuff if they commit to actually work with us. So they get to touch all this early stuff and help out. So it's not so easy, because we've tried it in the past, and sometimes people, they want the hardware, but then they don't do anything. They just want to say, hey, I have a beta of the Arduino, whatever, and then they just. So we're trying to figure out ways where we can, convince people to be participating in the beta more.
We are working very hard to involve people more and more. And for example, we recently involved a group which is actually porting retro games to the FPGA, and we are in the process of porting many games and emulators for retro computing on Vidor, actually.
Oh, that's fantastic. What game can you show us?
Well, I got a port of Pac-Man, actually, that's up and running, and soon you'll see much more.
It's not exactly professional type development, but even engineers have to have fun.
How long would you say it would take an average user who really doesn't have a lot of experience getting from 0 to Blinky with the command line interface?
This board here has different levels of users. So if you have never used an FPGA and you want to take advantage of what the FPGA can give to you, we have a way that you can just select a library, and when you compile that Arduino library, it automatically puts the code into the FPGA as well. So as a user, you can take advantage of all these cool stuff that an FPGA can do just like that. So that was a great first step to remove completely all this complexity.
Let me add that. The nice thing about this is that the FPGA acts as an expansion to the peripherals of the processor. So basically what you do is you just include the library to, say, enable a serial port, and you can either choose the one that's inside the chip or the one that's in the FPGA, and they use exactly the same APIs. And that's true for everything that we are doing. As I was mentioning, also the graphics library uses exactly the same APIs of the Adafruit ones. So if you have your code running on Adafruit graphics library, it runs on Vidor, outputting on HDMI, hardware accelerated.
So the step number one was to basically give the power of the FPGA to people without any worry about development tools. Then where Dario is working on this tool, this command line tool, is more for the people that know how to build FPGA software using Verilog, so they can use this thing to put together their code and put it on our FPGA. And there's a third tool that we were mentioning before that's going to be completely in the cloud, so you can visually put together some blocks. You design the inside of the FPGA completely visually, and then you press a button and the compilation happens in the cloud, so you can be even on a Chromebook or an iPad, and you can basically create FPGA. So it's depending on the level of user, you have 3 different tools, 3 different ways to do this.
Oh, that sounds awesome. I'm pretty excited to use it. Thank you very much.
Thank you.
Thank you.